Chapter 3 Mass and Weight. Index Mass on page 3, measuring mass on page 4, weight on page 5, measuring weight on page 6. Differences between mass and weight on page 7. Gravity and gravitational field on page 8. Gravitational field strength on page 9. Relationship between mass and weight on page 10. Inertia on page 11. Gravity on different planets on page 12. Worked examples on pages 13 to 14. Mass definition: the measure of the amount of matter in an object. Nature: it is a scalar quantity, meaning it has only magnitude and no direction. SI unit: the SI unit is the kilogram, kg. Smaller units include grams, g, and milligrams, mg. 1 gram is equal to 0.001 kilograms. Properties: mass never changes, regardless of location, whether on Earth, the Moon, or in space. It reflects the object's inertia, which is its resistance to being moved or accelerated. Common mistake: people often say weight when they actually mean mass. Measuring mass, beam balance. This compares an unknown mass with standard masses. It uses the principle of moments, which involves balancing torque. Lever balance. This measures mass using a mechanical lever system. Digital top pan balance. This is the most modern and accurate method. It uses electronics to detect force and convert it to a mass reading. Weight definition: the force of gravity acting on an object with mass. Nature: it is a vector quantity, meaning it has both magnitude and direction. SI unit: the SI unit is the Newton N. Formula: weight W equals mass m multiplied by gravitational field strength G. Weight changes depending on the gravitational field. For example, an object weighs less on the Moon than on Earth, but has the same mass. Measuring weight. Weight is measured using a spring balance or force meter, which is marked in newtons. The weight of an object stretches the spring. The amount of stretch corresponds to the force or weight. For example, a 1 kilogram object on Earth stretches the spring to 9.8 newtons. A 2 kilogram object would stretch it to 19.6 newtons. Importantly, spring balances give different readings depending on the planet. On the Moon, the same mass will show 1/6 the weight as on Earth. Differences between mass and weight. Mass is the amount of matter contained in a physical body. Mass is a fundamental property of matter. Mass has magnitude but no direction, so it is a scalar quantity. The mass of a body is independent of its location. It is constant throughout the universe. Mass is measured using a pan balance, inertial balance, or electronic balance. The SI unit of mass is the kilogram, kg. The dimensional formula of mass is m. Weight is the gravitational force attracting a body toward the center of the Earth or other celestial bodies. Weight is not a fundamental property. Weight has both magnitude and direction, so it is a vector quantity. The weight of a body varies depending on its location because the acceleration due to gravity changes with location. Weight is measured using a spring balance. The SI unit of weight is the Newton N. The dimensional formula of weight is mLt-2. Gravity and gravitational field. Gravity, a non-contact force that attracts masses towards each other. It causes objects to fall and gives them weight. Gravitational field, the region around a mass where it exerts gravitational force. It is represented by field lines pointing toward the mass. The closer you are to the center of a planet, the stronger the gravity. Examples of other action at a distance forces include magnetic force and electric force. Gravitational field strength definition: the force per unit mass at a point in the gravitational field. Formula: G equals W by m units. The unit is newtons per kilogram, which is equivalent to meters per second squared, meter per second square, when considering free fall. Values: on Earth, G is 9.8. On the Moon, G is 1.6. On Mars, G is 3.7. Dual interpretation: the value G can be interpreted as acceleration, meaning how fast objects fall, or as field strength, meaning how strong gravity is at a location. Relation between mass and weight formula: W equals mg, where W is weight in newtons, N, m is mass in kilograms, kg, g is gravitational field strength in n/kg or meter per second square implications. Mass is constant, but weight changes when g changes, for example, on different planets. Example, a 2 kilograms mass on Earth has a weight of 2 times 9.8 equals 19.6 n. On the Moon, its weight would be 2 times 1.6 equals 3.2 n. Inertia. Inertia is the tendency of an object to resist changes to its motion. It is a property of mass. The more mass an object has, the more inertia it has. Newton's first law describes inertia. Without external forces, objects naturally resist acceleration or deceleration. For example, in zero gravity, when astronauts push against a wall, they slowly drift backwards. Once in motion, they keep moving unless they apply another force. Gravity on different planets. This table shows the weight of a 1 kilogram object on different celestial bodies. On Earth, where g is 9.8 n/kg, the weight is 9.8 n. On the Moon, where g is 1.6 n/kg, the weight is 1.6 n. On Mars, where g is 3.7 n/kg, the weight is 3.7 n. On Venus, where g is 8.8 n/kg, the weight is 8.8 n. Worked examples. Example 1. On Earth, the acceleration of free fall is about 9.8. On Mars, it's about 3.7. The Mars rover Opportunity's weight on Earth was 1850 n. Part 1. Calculate the mass of the rover. Using the formula W equals mg, we rearrange to m equals W/g. So m equals 1850/9.8, which is approximately 188.78 kilograms. Part 2. Calculate the weight of the rover on Mars. Using W equals mg, we get W equals 188.78 times 3.7, which is approximately 698.49 n. Worked examples. Example 2. The gravitational field strength on Venus is 8.8 n/kg. The mass of a rock is 200 kilograms. Calculate the weight of the rock on Venus. Answer. W equals mg equals 200 times 8.8, which equals 1760 n. Example 3. The gravitational field strength on the Moon is 1.6 n/kg. The mass of a box is 15 kilograms. Calculate the weight of the box on the Moon. Answer. W equals mg equals 15 times 1.6, which equals 24 n.
Thank you for learning with us.